A river is a freshwater source that originates from mountains and flows through the lands and valleys. You may have seen a narrow river flowing silently and a roaring river violently. But have you ever think about a river flowing in the sea? Is it possible? If so, how does it happen? Well, that's the story for today's Green Letter. The rain over the hills and lands is one of the sources of fresh water. In India, during the southwest monsoon, all the rivers will get sufficient rain. Water from different tributaries merge to major rivers and finally arrives at the ocean. As you know, unlike the river water, seawater is very salty. The key factor is salinity. What does that mean? It's the amount of dissolved material in grams in 1 kilogram of water. For example, if there is 35 grams of dissolved material in 1 kilogram of water, then the salinity is 35 psu. You may notice salinity is a ratio, so it's a dimensionless quantity, but we represent this number as practical salinity unit or psu. For the river water, salinity is almost zero. But for the ocean, it's more because the ocean contains different ions like chlorine, sodium, etc. So salinity will be more. The average salinity of Bay of Bengal is 31 psu. So we can distinguish the river and seawater based on the salinity. Keeping this in mind, we are going on. The wind coming from the southwest brings rain clouds to the land and precipitate over the western regions of India. It's nothing but the southwest monsoon. The major rivers of India are flowing towards the east. The water gain during the southwest monsoon will take about 3 months to get discharged at the Bay of Bengal. Such a long journey. During the months of July to September, the rivers Ganges, Brahmaputra, Irrawaddy, Mahanadi, Godavari and Krishna together contribute about 130,000 cubic meter amount of fresh water per second. This huge amount of water accumulates at the northern Bay of Bengal and starts flowing towards the equator along the east coast of India. As it propagates further, fresh water starts mix up with the seawater, yet it remains relatively low saline. But how does it propagate only along the Indian coast? It can go on the other side also. Scientists revealed there is a coastal current flowing along the east coast of India, which is known as East India Coastal Current or simply EICC. EICC is a seasonal current which reverses twice in a year under the influence of alternating monsoons. The northeast and, as told before, the southwest monsoon. After the southwest monsoon from September, EICC flows equatorward. Thus the low saline water starts to flow along with the EICC. Oceanic currents are generated by wind stress, but sometimes local winds oppose the EICC, but surprisingly the current flows equatorward only, which means some other force is helping EICC to flow and intensify. Yes, the oceanic Kelvin waves. Winds at the equator generate oceanic Kelvin waves, which propagate only along the coast. At the equator, the zonal wind will increase, decrease, and even reverse. This oscillation pushes the equatorial water mass eastward like a wave. As a result, the sea surface height changes accordingly. Once it reaches the land boundary, it bifurcates and a part goes northward along the coast. As time passes, this Kelvin wave propagates forward and reaches the Indian coast. If there is a stronger Kelvin wave, there will be a stronger EICC. If EICC is stronger, the low salinity water extends farther south. In addition to Kelvin waves, oceanic eddies also enhances EICC and affects the freshwater propagation to be narrow or broad. So, this is now relatively low saline water propagation along the east coast of India, which looks like a river flowing in the sea. When this all were happening, a cold-blooded series of murders was going on near to you, maybe in front of you. Well, that's a story for another green letter.